Dear students, welcome to the first live session of the course Solar Energy Engineering and Technology. So here I have a brief presentation. I'll be now giving brief what the content covered so far. So this week we have week 5. So I'll be touching week 5 as well. The content covered to this date. So as I mentioned, there are 5 modules so far. In module 1, introduction to solar energy has been described, and module 2, solar radiation geometry has been elaborated. How these all angles are related in calculating the incidence angle, and every angle has been defined precisely so that there is no difficulty in understanding the significance of each and every angles. And also we have elaborated how this has been calculated, and also solar radiation estimations, how global radiations, then extraterrestrial radiation, that means on a clear sky, and average sunshine hour and maximum sunshine hours are related. That means how we can connect radiation data and meteorological data together to find global radiation. This has been elaborated extensively in module 3. In module 4, solar photovoltaics has been described, and it includes fundamentals, very fundamentals, and then it goes to different applications. And in module 5, exclusively standalone photovoltaic systems were discussed. So in lecture 1 of module 1, primarily it covers energy scenario. So the energy scenario, what is there? It was somewhat old, but in today's form, if I have to tell, like energy mix, so it is about 50.5% of energy is coming from fossil-based energy resources, and about 49.5% is coming from non-fossil-based energy resources. This includes large hydro as well. So in Indian context, if a hydropower plant having capacity more than 25 megawatt, then we consider as large hydro, and less than 25 megawatt we consider as small hydroelectric power plant. So there is a questions in the discussion forum, like how we can classify this. So this is the classifications normally we made. And in today's context, about 49.5% of energy is contributed from non-fossil based energy systems. And also there is elaboration about energy scenario for worldwide, and global trend of energy generation of renewable power has also been elaborated, and what is the expected trend in the coming 20 years, and how renewable energy is going to take part majorly in power distributions, and not only in India, in globally, that has been elaborated. And trend of generation of solar power has also been discussed. In lecture 2 of module 1, overview of solar energy conversion devices and applications has been elaborated, and what are different routes of exploiting solar energy. If we talk about solar energy exploitation, primarily we'll have two verticals. One is solar thermal, other one is solar photovoltaics. So in solar thermal, we can use the thermal energy in different forms, because we can categorize based on the temperature ranges. It may be low temperature scale, maybe medium temperature scale, or maybe high temperature scale. So medium temperature scale, low temperature scale, we can use it for household application, and then medium temperature scale we can use it for meeting different applications by MSMEs. It may be some factories which requires energy up to a temperature of 150 degrees Celsius from 80 degrees Celsius, or it may be tea industries. And also for high temperature applications, we can go for electricity generation. So we know Rankine cycle, so we can use the Rankine cycle and produce electricity. by generating steam. And also we have discussed devices for thermal collection and storage. What are different methodologies and devices we can use for thermal energy collection, and then working of PV generators, then concept of solar power plant were introduced in this lecture. In lecture 3 of module 1, primarily we have studied the physics of propagation of solar radiation from sun to the earth. So the intention of this lecture was to introduce like what happens when shortwave radiations comes from sun and passes through the earth atmosphere, and then what happens in the earth atmosphere. So this is majorly attenuated due to scattering and absorption. So what are the elements responsible for scattering and what are the elements responsible for absorption? This has been elaborated very precisely. And also how we can classify normal radiation and diffuse radiation. This has been exclusively elaborated in this lecture. And also sun-earth relationships were discussed, and different radiations like solar, we call it as solar insolation, sometimes solar irradiation. So these are different terminologies we use, and what is the meaning of those terminologies. This has been elaborated. And also the air mass. So air mass is talking about the thickness. Primarily, we can say thickness of the radiation has to pass through in the earth atmosphere. So it makes an angle with the normal to the horizontal surface. So if AM is 1, that indicates no sun is on the overhead. And then AM1 means AM 1.5 means no, it is slanted. That means solar radiation is falling from a particular direction, and it makes certain angles with the normal to the horizontal direction. And AM0 stands for radiation is above the earth atmosphere. That means it is in extraterrestrial region. So here air mass 1.5 is very, very important because what happens, this spectrum is normally used for testing of any solar devices. So mathematically, if I say, if we consider this is the earth surface and we have this is the normal to the horizontal and this is the zenith, okay, and if solar radiation is coming from here and it makes certain angles here, okay, and if I name it as A, B, and C, that means AB by BC will be cos of theta. Okay, cos of theta. So this will be 1. So AM1 indicates when AM1 indicates when the sun is here. Okay, and if we consider a person is standing here, so this sun ray is falling on the head, and then other angles can be found out by using this expression. So air mass is very, very important, and it tells about some kind of spectrum. Okay. So as we know, our spectrum range is something like this. So it goes something like this, and then it goes something like this. So here, this range is about 0.4 to 700 micron. Okay, this is micron or 0.7 micron, 0.4 to 0.7 micron, where we get this visible range. And here is UV, and the other side is infrared. Okay, so normally what we want this range for photovoltaic conversion. Okay, of course IR is used for a heating effect. In lecture 1 of module 2, primarily solar radiation and sunshine measuring instruments were discussed, like what are the equipments used for measurements of different radiations. It may be global radiation, it may be normal radiation, or it may be sunshine hour. So we can have pyranometer, we can have pyrheliometer, or we can have sunshine recorder. Okay, so pyranometer actually gives it is something like we have this kind of dome. Okay, this kind of dome, and this is like hemisphere, and this portion is evacuated. Okay, so that we can have lower heat losses, and at this place we'll have a black surface. So even though I'm indicating in red, it should be black. And when solar radiation comes and passes through this, no, of course, nothing is here because it's evacuation, and this will pass through and it will strike here. Okay. And since this is black, and here most of the radiation will be absorbed, and its configuration is something like this. Okay. And there will be some kind of support system. And as we know, the principle of thermocouple, if two junctions of two dissimilar metals we join, okay, and we keep them at the different temperatures, it may be TH and this may be TH, then it is expected to get EMF. Okay, and this is calibrated in such a way that the amount of EMF we generate in the system will be converted to watt per meter square. So that means at the particular point of time, what is the solar radiation falling, we'll get in terms of watt per meter square. And for this case, here we are attaching one thermocouple, and sometimes we use thermopiles. And here is another junction, and then we connect them, and we measure EMF. Okay, and it is calibrated. So this is one configuration for measuring global radiation. So as you are aware that we'll have global radiation, we have normal radiation, then we have diffuse radiation. So what I said, that this instrument pyranometer is used for measurement of global radiation, and the same instrument can be used for measurement of diffuse radiation by providing a shading ring on the top of it. What is the purpose of this? So when we are attaching this shading ring, then we are restricting the normal radiation to pass through. Only diffuse radiation can come in and then contribute in the heating effect, so that we can measure the watt per meter square under that condition, and that will give you diffuse radiation intensity in watt per meter square. And then use of radiation, as I said, insulation, and then some radiation data. Okay, and what kind of radiation and what kind of wavelength, radiation wavelength is used in what application, this has already been elaborated. So in lecture 2 and 3 of module 2, we have studied radiation geometry, which is very, very important. And irrespective of the kind of utility we study, this knowledge is very, very important. Without this knowledge, we cannot design any solar no systems. It may be solar thermal, or it may be solar PV, or maybe solar PVT systems. So we'll have different solar angles. Say, for example, we have declination. So we have latitude, then longitude. We have solar azimuth angle, then surface azimuth angle, then we have altitude angle. So these angles were elaborated. So for your understanding, just to elaborate, say if this is the globe, and if we are targeting for a location where we would like to know the phi, that means it's a latitude. So what we can do, we can connect the place to the center of the earth and project it on the equatorial plane. Okay, and that angle, what we'll get in the projection is your phi. And if we connect the center of the sun and the center of the earth and project on the horizontal plane, and this is nothing but delta. Okay, and also mathematically we can express delta, which is nothing but delta is 23.45 sine of 360 by 365 and 284 plus n. So n is the end day of the year. It may be January 1 or maybe January 2 or something like that. If it is say February 21, then it will be 31 is the January month, and then it is 21. Then we can find out it is 22, 2 and 5, 52. So n will be 52. So if we substitute the value of n here and other things are known, we can find out what is delta. So these angles, how to find out, has been elaborated, and importance were discussed. Along with that, we have local apparent time. So it is also known as solar time. So every calculations for finding out hour angle. So what is hour angle? So hour angle is something like, this is very, very interesting. So when we are calculating radiation parameters, sometimes we use it on hourly basis and sometimes we use it on daily basis. Okay, so that's how we express different terminologies. So sometimes we use IG is the global radiation. This is instantaneous, I can say. And if we know place a bar on it, then it becomes average hourly global radiation. Okay, so see, Cleans, there is a researcher, his name is Cleans. So he has recommended some dates of a particular month, which gives the what is called representative data for the radiation. So that means we don't have to do the radiation calculation for the entire month. So for a particular month, only one day is enough. Okay, and that day has already been identified. So if we know the n value of the particular month, which gives the representative information, then it is very good. Then that will give you the average values of the particular month. That means for January it is 17th January. So if we consider n is 17th, and it is found that if we do the calculation for n is equal to 17th, it will give the average of the particular month. Okay, so we can actually do for January 1, then January 2, then we can continue till January 31, and we can do the averaging. Then that will give you the average. That is not required. Only one calculation is sufficient. So if we do the 17th radiation calculation on 17th, that means on that day we can actually find out this values IG giving a bar. That means this is an average values. So this IG is for hourly average, and we can also find the daily average. So this may be HG bar. It gives daily average values. Okay, so that means we need to integrate over the entire hour angle. So what is the integration? It is from minus or this side is minus after sunset. What I mean to say, in the afternoon it is minus omega. This is plus omega. Okay. So if we integrate over this, then what we are going to get the entire HG values. Okay. So now my concern is, say there is a question in the discussion forum, like hour angle, how to measure the hour angle. If this is the case for IG, okay. So what I will say, if we consider this hourly, and if we consider the hour is 11 to 12 o'clock, during this time we need to measure the radiation spectrum. Okay, and here we know 1 hour is equal to 15 degree. Okay, so if it is IG, we need to find that is hourly. That means 11 to 2 is the, say for example, our timing at which we need to find out omega. Then our time will be actually 11:30. So at mid of this hour, we need to find out this hour angle. So this will be somewhat like 15, or you can say 15 by 2. That means 7.5. Okay. So straight away we can find out this what is called omega. If it is no LAT. Okay, this is LAT. Okay, fine. But HG is different because their expression altogether will be different. So there will be omega, which will be outside, and there will be multiplying term. Okay, and this will be in radian and others will be in degree. So that's how this omega is calculated. Also, Sanpat diagram is discussed in this 2 lectures. In lecture 1 of module 3, and then correlations and calculation of extraterrestrial radiations were discussed, and why these correlations are required. So here we must bring some information, like say for example, you don't have any measuring instrument for radiation, and also you don't have any data for similar kind of climatic conditions. So under that condition, we can actually use some kind of correlations to know the radiation spectrum of a particular place of consideration. Okay. If we have radiation data, then it's fine. We can straightway use. If we don't have, then we can rely on correlations with some accuracy. Of course, error will be there. It is not 100% accurate. Then we have also studied about weather classifications, then calculations of monthly average of daily extraterrestrial radiation, then different correlations for estimation of monthly average of daily global radiation. And in lecture 2 of module 3, we have studied the estimation of solar radiations. Like we have done the classifications based on hourly, or it may be daily basis. Okay, so there are a host of correlations developed by many researchers by considering only beam radiation, precipitations, it may be meteorological conditions. So different conditions they have considered, and also it is cloudy sky or clear sky. So numerous such kind of no correlations are available, and we have seen the no deviations. Suppose one correlation is developed for say Hawaii in USA, the straightway same correlation cannot be applied for a place like Guwahati. It is something like that. So we need to study the meteorological conditions and other aspects of particular locations for a long period of time. Then only we can come up with some kind of appropriate correlations. And that's how we have solved many problems to understand really the importance of the meteorological conditions of a particular locations. In lecture 1 of module 4, we have studied solar PV conversions, starting from importance of conversion and challenges, then construction of PV cells, then manufacturing of silicon solar cells, and what is the working principle, how band gap energy is calculated, why this band gap energy is so important as far as electron hole pair formation, and then finally electron mobility is concerned. Also at the end we have elaborated something about loss mechanism of the PV system. In lecture 2 of lecture module 4, semiconductor physics were discussed, because this is the foundation. Otherwise, it will be very difficult to what is called understand the workability of semiconductors. So we have started with classification of semiconductors. It may be intrinsic or extrinsic semiconductor, and then doping, what kind of dopants are used, then the Fermi energy level, then PN junction, what is drift current, and the other current, and diffusion current, that means, and then generation of solar cell material, like first generation, second generation, third generation. It will first generation, if we say, it's like no people are least bothered about the cost. Only people are looking about the how to increase the efficiency. In the second generation is cost was the primary issues. Can we have low cost solar cells? But in third generation, we need to reduce the cost as well as increase the efficiency. That's the trend of classifying these generations of solar cell material. So this has been elaborated in these lectures. And in lecture 3 of module 4, performance characteristics of PV cells are discussed. That means what is the importance of field factor, short circuit current, the open circuit voltage, maximum current, the maximum voltage, and then how we can define maximum efficiency, and also this other important parameter which really give an idea of design of a good solar cells. And also we have derived the estimation of maximum power of a solar cell. So we can have solar cells, and we can get the parameters, and we can do the analysis, and we can find out the maximum efficiency. Apart from that, theoretically also we can actually maximize, and we can estimate the maximum power delivered by a single cell. Also, we have discussed about variation of solar insolation and temperature on the characteristics of solar cells. And then how this band gap energy is actually impacting on the efficiency of solar cells also elaborated in this lecture under the module 4. In lecture 4 of module 4, solar module arrays and PV systems were discussed, and this is about system level. So already in the last lectures, we were very much particular about the cells. Now in this module, primarily modules performance, and then what are the effect like effect of shadowing, then packing factor, how densely we are occupying the modules in the frame of making modules, and then what is module efficiency, and what are different ways of maximization of PV cell performance, then maximum power point tracking and possible strategies for operation of MPPTs were elaborated, and PV arrays, and also at the system level how we can use this solar energy for power generation and for meeting other requirements. And in module 5, primarily we have discussed about standalone PV system, and what are different component comprises of a standalone PV system. These were very extensively discussed, like PV module, charge controller, what is the function of charge controller, and what is the function of battery, inverter, load, and how they are connected, and what are different design steps of a standalone PV system. And finally, we have solved numerical problems to strengthen the understanding of a standalone system. So thank you very much for your attention. So these were discussed so far, and we have addressed some of the queries which is made in the discussion forum. And now if you have any queries, and you can ask me, I will try to make you happy. So let me check if someone is. So there is a question. It is said that the angle of incidence formula cos theta is difficult for me to remember, since I believe this is a basic for any other formulas. Could you please suggest an easy way of understanding and remembering? I think you don't have to worry about it. If we have to ask some questions, then this long expression for cos theta will be given to you. So this is not a big thing. But what is important, how to solve this kind of problem, how to calculate omega, how to calculate delta, how to calculate phi, because in calculating phi also, you will be given, say, for example, Guwahati city, it is say about 23 degree and then 25 minute. So how to convert minute to degree, these things you need to learn. But long formulas, anyway, everything will be provided to you as far as exam is concerned. So I hope this course is very interesting to you all. So if you have any questions, you can ask me. Yes, yes. Solar engineering technology is sustainable power generation. Yeah, there are some queries. Um, so engineering, solar energy engineering, and then technology and sustainable power generation. Both courses are interdependent. These courses are useful for renewable energy. Of course, these courses are very useful for renewable energy industry. What are the benefits to give exam after this course for exams, and what are the benefits of NPTEL certificate? Please explain how it can be useful. So there are very funny questions. Benefits of giving. What sentence you have written? Please frame it properly. Then first thing, as far as benefit is concerned, it has got multiple benefit. Now you can earn. I don't know your background. So if you're a student, then you can earn credits. And if you do well in the NPTEL exam, then you are eligible for applying NPTEL fellowship. It's called pre-doc fellowship. So the NPTEL is giving about 25,000 per month salary, and then 1 lakh rupees contingency. So it's a good opportunity to take if you are really serious in doing this kind of NPTEL courses. And there is a question called kindly advise some books for reference and solve some more numerical problems, as the book mentioned in this is mostly out of market. I think we have solved sufficient number of problems in this course and also in assignments. So I suggest you to involve in all the assignments very meticulously, then I think that will give you comprehensive understanding in solving all kind of problems. Because no, we have made it after consulting many books and then formulating those problems to benefit the students in detail. Awesome. Thank you so much. So there's a question on tandem solar cells over single junction. So name itself, it is quite clear. So we have like single junction, only the one junction will be there, N type and P type, and then only one junction will be there. In tandem cells, it's like building blocks. One cell and then one more cell and then one more cell will come. So it is expected that that kind of tandem cell will give you more energy conversion. Sometimes we can have different material in those cells. So idea of making tandem cell is for higher energy conversion and higher efficiency. Any made in India software, I think we need to check in the net and then you must ask ChatGPT can help you to make some kind of made in India cell. Uh, Famous um, software is like PVC software is for grid connected PV system, and one more is Polishan. It's a German based, but in Indian context, I don't have much idea at the moment. So I hope this clarifies about our angles, which is raised by Jogesh engineers, Jogesh Patel, the faculty from some of the engineering colleges. And also one of the queries like assignment one, and this problem actually no this corrected option is 937.44, and because of this ambiguity this what is called questions has been removed from the evaluation. And in week 3 also there is question number 7 and 8, and this has been removed. If you have any questions, please post your questions. If software is included, all the calculations is useful to remember manual calculation process. So this is not a question of remembering something. It's a course where people have to learn how to do calculations. Then these softwares are not like no black box. You give something and then no you expect something from the software. You have to learn each and every step. Then only you can ask the software to do some kind of problem solving. All the questions, no, but there's a question like examination should be in MCQ mode or elaborated answer mode. So all the questions will be MCQ. What will be the final question paper? Better. So one more question in the set box, like in a team set box. They say they're asking like what will be the final question paper? All no question papers will be MCQ. But different types of questions will be there and marking will be different. But question will be MCQ type. So Mr. AK Sharma is again asking, cannot hear you. So I'm saying if software is also if a software is available, then also you need to know what is how to do the calculation for measuring all this kind of radiation spectrum or maybe radiation quantification and then PV calculations. So without knowing the fundamentals, it is very difficult to solve a real life problem. So you cannot have something, you cannot think and give something to the computer and you expect something from the computer. You must know what is going on inside. So that's what I try to uh, discuss. So there is a question currently which solar cell are using in current industry like Adani and Tata. So mostly these are no silicon based solar cells. So in market, what you see more than 90% solar cells are silicon based solar cell. It may be monocrystalline or multicrystalline silicon solar cell. Yeah, I think you should go for what is called Polyshan software, okay, for solar thermal calculations. It's a good software. You can design many components as well. So for solar thermal, you can go for Polyshan. Francis is also there. Uh, there is a question like it would be better if you provide a simple question paper, 1 and 2 for practice purposes. So I think you don't have to worry much if you are really doing good in solving all those assignments. You can score very good marks. And the questions will be asked from there only. So you please do the practicing of all assignments and also follow my lectures. And that is more than enough to get 80% marks. So if we have no more technical questions, we can conclude the session here. Okay, students, thank you very much for coming online and interacting with me. I'm closing the session now. I hope you will get a lot of informations and useful too in implementing in solar power plant or maybe in household as a household activity, a household utility. So thank you very much for registering in this course. Thank you so much.